In this section we're going to look at how to name some carboxylic acids and then how to name some esters which are derivatives of carboxylic acids and their reactions with alcohols. So there's a really horrible picture of a sweaty foot there. Now people have got different smells or sweat, but all people's feet sweat. So isovaleric acid is the common name of the acid that you can smell when you can smell sweaty feet. So let's work out the IUPAC name of the isovaleric acid. So it's got 1, 2, 3, 4 carbon atoms, and there's your carboxylic acid group. And if we draw out the full displayed structure, it's got 4 carbon atoms. Here's a methyl group on carbon number 3. If you put on all the hydrogens, you can see the carboxylic acid group takes priorities. That's on carbon 1, so we don't need to name it carbon 1. But on carbon 3, you have a methyl group. The stem is bute because it's got 4 carbons. So this is 4-methyl butanoic acid is the stuff that your feet produce when they're sweaty, or isovaleric acid. Let's now look at how to name this acid. First of all, we look for the longest stem, which is 1, 2, 3, 4. 1, 2, 3. So 4 is the longest, so its stem is going to be bute. And it's got a methyl group on carbon number 2. So that's simply 2-methyl butanoic acid. 2-methyl butanoic acid. This acid looks a lot more complicated, but it's not really. Let's number the carbons. 1, 2, 3, 4, 5, 6. Or 1, 2, 3, 4, 5, 6. So 6 carbons either way, so the stem is hex. So it's going to be a hexanoic acid. So if we go from carbon 2, we can see we've got an alkyl group here which has got 4 carbons. So because it's got 4, we would use the prefix butyl. So it's 2-butyl hexanoic acid. Let's now look at naming esters. So esters are a product of condensation between an alcohol and a carboxylic acid. Condensation means the loss of a small molecule. So for example, here is water. So if water is taken out, the two are condensed together and we get our ester. The name of the ester is methyl ethanoate. The methyl comes from the alcohol. The ethanoate comes from the carboxylic acid part of the ester. So methyl ethanoate. Esters tend to have a nice fruity smell. Pentyl ethanoate is the smell that is present in bananas. It's going to be made from an alcohol, pent, so it's going to come from pentanol, and ethanoate suggests it's condensed with ethanoic acid. So to draw the structure, it makes sense to draw the structure of the alcohol and the structure of the acid. Condense the two, taking away a molecule of water, and there is the structure of pentyl from the alcohol, ethanoate from the carboxylic acid, and don't forget the molecule of water that's released when they have condensed together. The ester that gives the common smell to green apples is methyl butanoate. The alcohol it must have come from was methanol, and the carboxylic acid it condensed with must have been butanoic acid. Draw the structure of the alcohol, the methanol, and the butanoic acid. Remove a molecule of water. There's the ester link. And don't forget a molecule of water is produced as well. So don't forget your H2O. So that is a condensation reaction. And this here is your ester linkage. So that's meant to be a bottle of rum. The smell in rum is caused by the ester ethyl methanoate. So first of all, the alcohol must have been ethanol, methanoic acid. Condense the two together, take away a molecule of water. There is your ester link, ethyl methanoate plus water. Fruity smell of pineapples is caused by the ester ethyl butanoate. So ethyl must have come from the alcohol ethanol. Butanoate must come from the carboxylic acid butanoic acid. Draw the structures of the alcohol, ethanol, eth, stem, ethanol, and butanoic acid, 4 carbons, butanoic acid. So there's the carboxylic acid group, the acetyl bondo, and the rest of the alkyl group. So we've just summarised it here. So CH2 twice, CH2, it's 4 carbons. Lose your molecule of water. There's your ester link. Let's highlight the ester link again. And a molecule of water is released because it's a condensation reaction. Apricots have a fruity smell because, again, they contain an ester, which is pentyl butanoate. So we rush through this one. The alcohol must be pentanol. The carboxylic acid must be butanoic acid. Draw the 2 structures, take away water, and you've made your pentyl butanoate. But this time what I've done is to show the skeletal formula for an ester. Pentyl has got 5 carbons, 1, 2, 3, 4, 5. And the butanoic acid, we don't draw this carbon atom here for the carbonyl groups. That's carbon 1, 2, 3, 4 for butanoic acid. So this is the skeletal formula for pentyl butanoate, and this bit here is the